Let's take a look at properties of logarithms. And we got three main properties. First one, if you have log of something plus log of something, addition becomes multiplication. So log p plus log q is going to equal to log p times q. And it goes both directions. If you have addition, you can rewrite it as multiplication. If you have multiplication, you can split it apart that way. If you have log of something minus log of something, well, subtraction, and that's really vague, isn't it? Something and something. But it can be anything within reason. You can't have negative numbers and zeros, but so if we have subtraction, that becomes division. So we got log of p divided by q. And if we got p log q, where typically it's a number it's out in front of your log, then you can take that and you can put as your power. Now this is the product rule up here, this is the quotient rule, and this is the power rule. Not that the names are that important on these. Let's take a look at our first problem. Log base 3 of 27x. It says use properties logs to expand each log expression as much as possible. Where possible, evaluate the log expressions without using the calculator. So we want to split these into separate logs. Now you have to look at the main thing that's happening inside your parentheses, and there's not much here, it's just multiplication. It's 27 times x. So from property 1, multiplication becomes addition. So we'll rewrite this as log, these are both base 3, log 27 plus log x. Now it says where possible, evaluate the log expressions. Well, that's this one here. Now here we got our base is 3. If you can rewrite the number that's following as 3 to a power, which we can in this case, this is 3 to the third. If you get these two numbers matching right here, then the log and the 3 is going to cancel, and we're just left with the exponent, which is 3. So our answer to this problem is 3 plus log x. Let's look at this one. Got log base 2 of 16 over x. Well, the main thing happening in this problem is division, and division from property 2 we can rewrite as subtraction. So this becomes log of 16 minus log of x. Well, we do have a number, so our base is 2, so we try to rewrite 16 as 2 to a power, and it becomes 2 to the 4th power. Now again, if the 2's match here, then the log and the 2 is going to cancel, and you're left with the exponent. So 4 minus log of x. In this one, we have log of p to the third. Property 3 says if you have a power, you can take that power and put it out in front of your log. So this becomes 3 log p. Now our goal on these is to get the if we can, the log x, log y, log z, log whatever variable we have by itself. So you don't want it mixed up into all this. You just want a single x here if you can, or single y, or single z, or whatever variable. Where to use this at? Well, this is kind of a calculus concept. If you go on to Business Calc or Calc 1, you'll find it's very beneficial in some cases to split these up into separate logs. So it's really just a technique to solve other problems, in case you're wondering. So here we got log of x to the 5th, y to the 3rd, over z to the 4th. Okay, again, you have to see what the main thing happening here. Main thing happening is we got something on top divided by something on the bottom. Well, from property 2, division becomes subtraction. So we're going to rewrite this as log x to the 5th, y to the 3rd, minus log z to the 4th. Now look at my first parentheses here. The main thing happening in this is multiplication. X to the 5th times y to the 3rd. So from our first property, multiplication becomes addition. So we got log x to the 5th plus log y to the 3rd minus log z to the 4th. Now, going back to this, I said multiplication is the main thing that's happening. The 5th power isn't, because not everything's being raised to the 5th power. So again, the main thing on here is trying to figure out what's the main thing that's happening. Now, the x, y, and z are not by themselves yet, but from property 3, we said if we have a power, we can put it out in front. So this is going to become 5 log x plus 3 log y minus 4 log z. And the x, y, and z are by themselves, of course with the log in front of them and so forth, but that's our answer. Let's look at our 5th one here. We got log base 3 of the 4th root of x squared y to the 5th over 27z. Well, we know whenever we have radicals, we want to get rid of the radicals. So let's start there. We're going to rewrite that radical as the 1/4 power. Now remember, whatever number is in this little slot right here, that's called your index. That goes in your denominator. And then you just put a 1 up on top. These are all different powers, so we can't find any consistency there. Okay, main thing that's happening here. We got something nasty inside of parentheses to a power. So the power is the main thing. We're taking everything to the 1/4 power. Well, from our third property, we can take the 1/4 and put it out in front of our log. And we're left with this. X squared y to the 5th over 27z. Now the main thing happening. Well, we got something up on top divided by something on the bottom. So the division's our main thing. Now the 1/4 that we put out in front has to stay out in front of every log we write from here on. So this becomes 1/4 log x squared y to the 5th minus 1/4 log 27z. Okay, look at our first parentheses here with the log. We have x squared times y to the 5th. The main thing that's happened is multiplication. And again, as I rewrite this, we rewrite multiplication as addition. I have to put the 1/4 out in front of each log. So we've got 1/4 log x squared plus 1/4 log y to the 5th minus, now I'm going to put a parentheses here because this negative has to affect everything that follows it. So as we rewrite this log over here, it has to change the sign of both of these. Well, I got 27 times z, that's multiplication. So I'm going to have 1/4 log 27 plus 1/4 log z. Now again, the 1/4 has to be out in front of each one of those logs. Okay, so looking at the x squared here, I can take the power, put it out in front. So we got 2 times 1/4 log x plus this 5 we can take out in front. 5 times 1/4 log y. This negative has to flip the sign of everything that follows it. So it's a flip sign of that and flip sign of that. So this becomes minus 1/4 log 27 minus 1/4 log z. Now 2 times 1/4 is 2/4 or 1/2. So we've got 1/2 log x plus 5/4 log y minus 1/4 log 27 minus 1/4 log z. Now, this 27, you might be looking at that and say, well, I can simplify that, but you can't. Think what our base is. There is no number here, so it's by default base 10. There's no way we can rewrite 27 as 10 to a power. So this would be our answer. Let me start a new tablet, and then we'll look at the next problem. Got a natural log of e squared x to the fifth, fourth root, 3 plus x over 5 times x minus 2 to the fourth. Well, I know in my first step I'm going to rewrite that fourth root as the 1/4 power. We'll get to that. The main thing that's happening here is we got something nasty on top divided by something nasty on the bottom. So division is our main thing. So division becomes subtraction. So I'm going to have ln of e squared x to the fifth and 3 plus x to the 1/4 power. Again, whatever number is in this little slot, that's called your index. That goes in your denominator. And then we put a 1 up on top. Minus natural log of 5 times x minus 2 to the 4th power. Now looking at our first bracket there, the main thing that's happening is multiplication. We got e squared times x to the fifth times 3 plus x to the 1/4. So we got three things multiplied together. Well, we can split them up. Multiplication becomes addition. So we got e squared, or natural log of e squared plus natural log of x to the fifth plus natural log of 3 plus x to the 1/4. Minus, now put parentheses here because this minus has to flip the sign of everything that follows it. The main thing in this second bracket is multiplication. We got 5 times x minus 2 to the 4th. So we rewrite multiplication as addition. So we got natural log of 5 plus natural log of x minus 2 to the 4th. Now in our first part here, this natural log, that's base e. So if I were to put an e there, remember if these match, then the e's and the natural log cancel away and just leave you the exponent. Now our second one here is the main thing that's happening is the 5th power. So we can take the 5 and put it out in front. So we've got 5 natural log of x. Here the main thing happening is the 1/4 power. So we can put it out in front. So we've got 1/4 natural log of 3 plus x. Now this negative is going to flip the sign of everything here. So this becomes a minus natural log of 5 minus, and here we got a power, so we can put that out in front. So that becomes 4 natural log of x minus 2. Now we would like to get the x by itself, but in this particular problem we can't. So that would be our answer. Because we don't have anything that allows us to split up a natural log of two things subtracted. Our only formula says that if we have log of something minus log of something, you have two logs. This just has subtraction inside of one log. Oh, I didn't say it, but natural log of 5, I can't simplify that. The base is e, and there's no way I can rewrite 5 as e to a power. Well, let's look at some problems going the other direction. We got log base 3 of 54 minus log base 3 of 2. The instructions say use properties of logs to condense each log expression. Write the expression as a single log whose coefficient is 1. Where possible, evaluate without using the calculator. So we're going the other direction. We got separate logs. We want to end up with a single log. Now this technique is used in the next particular section where we're solving logarithmic equations. So this is a college algebra technique. Those ones above are calculus based. Well, if we have log of something minus log of something, subtraction becomes division. So this becomes 54 over 2. And 54 over 2 is 27. Now since it's a number, we see if we can simplify it. Our base is 3. So we're going to try to rewrite 27 as 3 to a power. And we can rewrite it as 3 to the 3rd power. Well, now if these 3's match right here, then those 3's I just circled cancel away, and the log cancels away, and we're left with the exponent, which is 3. Let's look at this one. We've got 4 log base 2 of x plus 7, assuming base 2, of y. Now we can't use our addition and subtraction properties unless the log is by itself. There's no numbers in front of it. Notice on number 7 there was no numbers in front of this log, there was no numbers in front of this log. So that's why we could do it. So our first step here is to take our number that's in front of the log and put as our power. So take those, put those as our power. So this becomes log of x to the 4th plus log of y to the 7th. Well, here we got addition. Log of something plus log of something. Addition becomes multiplication. So this becomes log of x to the 4th, y to the 7th. And that's our answer. Let's look at our next example. 2 natural log of x plus 3 natural log of y minus 4 natural log of z. Now again, before we can use our first two properties, property 1 and property 2, we have to get rid of any numbers that are in front of our log. So this 2 I'm going to put as my power, this 3 I'll put as my power, and this 4 I'll put as my power. So this becomes natural log of x squared plus natural log of y to the 3rd minus natural log of z to the 4th. Now on these, the way you handle it is using your order of operations. You do it as you encounter it from left to right. So this is my first one, so I'm going to handle that. Well, we got log of something plus log of something. Addition becomes multiplication. So this becomes natural log of x squared y to the 3rd minus natural log of z to the 4th. And now we'll handle these two. Here we got log of something minus log of something. Subtraction becomes division. So we got natural log of x squared y to the 3rd over z to the 4th. Now our goal is to get a single log, which we just achieved. So that's our answer. Let me grab a drink here. Okay, so we got 1/5 log base 3 of x minus 4 log base 3 of y plus 5 log base 3 of x minus 7. Well, think back to your order of operations. Your order of operations tells you to do what's inside the parentheses first. So we look at inside the parentheses here. Well, we could normally use the subtraction, the minus here, and rewrite as division, except for there's a number in front of the log. So first thing I'm going to do is take that 4 and put it as my power. So this is going to become 1/5 log x minus log y to the 4th. Now I know eventually I'm going to have to put the power on this one anyway, so let me go ahead and do it. Because we can't use any of the other properties unless there's no number in front of the logs. So here I'm going to rewrite this as x minus 7 to the 5th power. Okay, back to inside the parentheses. Here we have log of something minus log of something. Subtraction becomes division. So this is 1/5 log base 3 of x over y to the 4th. Plus, and then I'll bring down the rest of this. Now you notice after I combine those together, there's no need for the parentheses anymore. Now here we have log of something plus log of something, and addition becomes multiplication, assuming the logs don't have any numbers in front of them. We have a 1/5 in front of this one, so we're going to take that and put it as our power. So this is going to become log of base 3 of xy, or x over y to the 4th to the 1/5 power, plus log of x minus 7 to the fifth. That's 1/5 power. Sorry, did I say fifth power? Going see now. Okay, well 1/5 is the fifth root, so I can rewrite that in radical form. Most books will probably do that. X y to the fourth plus log of x minus 7 to the fifth power. Well, now we have log of something plus log of something, and our property says we can rewrite addition as multiplication. So this becomes fifth root of x over y to the fourth times x minus 7 to the fifth power. And that's our answer. And let me start a new page here. And we've got natural log of x plus natural log. My wife's calling, I think, so I'll probably have to listen here in a second to see if she's broke down. Nope. Okay. They're talking about my birthday. Blah, blah, blah. Okay. I wish I could turn the volume down on that silly answering machine. Okay, now look at this. I notice that none of the logs have numbers in front of them. So it's in perfect form for using the first two properties. Now we're going to do it from left to right. So I'll do these first two here. We got natural log of something plus natural log of something. Addition becomes multiplication. Hopefully you couldn't hear all that answering machine business. I was having trouble focusing myself. Now, if they were like planning something really special for me, like bringing Goldie Hawn in for my birthday, then I would have stopped the recording, But showing my age, I guess. Anyway, addition becomes multiplication. So x times x squared minus 9. Okay, let's do the next one. Here we got log of something minus log of something. Well, that becomes division. So we got natural log of x times x squared minus 9 over 7 minus natural log of x plus 3. Now let's think about how we did this division. We put the x times x squared minus 9 up on top, and we put the 7 down below. So what followed the minus went down in our denominator. Keep that in mind. Now we have log of something minus log of something. Well, subtraction becomes division. So I got x times x squared minus 9 over 7 times x plus 3. Here we put the 7 in the denominator. Here we put the x plus 3 in the denominator. So whatever follows your minus always just goes in your denominator. Well, this one has another little trick to it. The x squared minus 9 is two terms of minus between it. That's a difference two squares. So it can factor as x plus 3 times x minus 3. And once we do that, we see we can cancel something. Here's an x plus 3 and here's an x plus 3. So those are going to cancel. And we have natural log of x times x minus 3 over 7. And we got our single log. And that's our answer. Now the next two we saw in a previous lesson, but let's refresh our memory. Now this says use common logs or natural logs in a calculator to evaluate to 4 decimal places. Well, we're going to use the change of base to rewrite this. So this becomes log of something over log of something. Specifically, 13 goes here and the 5 goes here. The way it always works, change of base, whatever follows a log goes up on top, and whatever's right here goes on the bottom. Or, if you wanted to, you can rewrite this as natural log of 13 over natural log of 5. Change of base says you can actually rewrite it in terms of any base. Now the only two that actually make sense for the calculator are those two. Because if I go look at my calculator, I have a log button and I have an LN button, natural log. So I don't have any other base. Like I say, it doesn't matter which one you pick. I'm still in graph mode over here, so to exit out of graph mode, you just do second mode. And we want log 13 divided by log 5. So press log 13, closing parentheses, divided by log of 5. Enter. In 4 decimal places, we got 1.5937. And that's our answer. When I worked on the Air Force Base, teaching on the Air Force Base, I had not one of my students, but I had a student one semester asked me if I could tutor him in logs. And I said, yeah, that's no problem. I can do that. I work with it all the time. And I sat down with him, and instead of using a calculator like this to find a log, he needed to use tables. I wasn't very much help. I hadn't used tables for many, many years, probably like 12 or 14 years. And I told him I couldn't help him. I just never had used, I hadn't used tables forever. And it wasn't that I couldn't learn, I just didn't have time that semester to actually learn it. Well, it's like, why would anybody use that if you got a log button on your calculator? And about every scientific calculator, even the cheapest ones down there at the store, have a log button. Well, in case of a military, if they have like a nuclear attack, or even there's some devices specifically designed for that, they get that electrical magnetic EMP, I think is what it's called, where it wipes out all electronics. Well, if you don't got a calculator that works, it's been wiped out, well, you need to figure out some way to attack the enemy back. And so they have to be able to do logs by hand. I thought that was interesting when he explained that to me. Let's take a look at number 13. This wants us to graph this using the change of base. So we got 5, and then we got x plus 3. Again, obviously we can't put it directly into our calculator because we don't have a base 5 button. I'm going to use ln. So ln of something over ln of something, natural log. So we'll have natural log of x plus 3 over natural log of 5. Again, whatever follows your log right here goes on top, and whatever your base is goes down here. Let's go graph this now. So press my y equals, press clear, and I got natural log of x plus 3, closing parentheses, divided by natural log of 5, closing parentheses, and then graph. Now these never just stop. It's kind of like those trains that keep going by my house. They never stop. Whine, whine, whine. Won't he ever stop whining? Okay. This never just stops. It keeps going forever. It's a flaw with the calculator. I don't know why, but they even haven't even fixed it with the newer calculators. Must be something that can't be fixed, if I had to guess. But that would be our graph. And that's actually the end of the section, I believe. Let me see. Yeah, it is. So let me stop the recording.